Testing, testing, testing. Let me get a test here. Test, test. Okay. Let's see. Today is November 7th, 2018. I'm starting a couple of minutes a little bit early. I do have the volume turned up more so than usual today because we're going to be looking at a couple of videos. First thing I'm going to talk about a little bit about is creating indexes. What's an index? What's an index in a book? A list of the topics that take you directly to, so that's a topic index, and that takes you directly to the pages where that is. I could index the pictures. So if you ever do a dissertation or something, you'll have to have an index to all your pictures, you'll have to have an index to all of your graphs, and it will be a real pain in the neck. In a library, there are three main indexes. So the three indexes are the topic of the book, the title of the book, and the author's name are all. So, for example, I might have a book of books about whales, and in whales I would find Moby Dick. I would find textbooks on cetology, that's the study of whales. Other stuff. I might look under the index of the author's name and I would find Herman Melville, and under that I would find all of the books by Herman Melville, one of which is the epic Moby Dick. And then again, the other one would be the title. I could look up just the title of the book and I could find out the author's name and the topic. Right, there are three of them, three main indexes. And these used to be, back in the old days, they consumed a big piece of real estate in the lobby of the library. Nowadays, they still consume a big piece of real estate, but it's on the server because almost all of them are electronic. Mixed up. Oh yes, it's the architect's idea. He said it looked neat. Not easy made. It doesn't make it easy to find the book you want. Oh, well, maybe I can help. So what was it exactly you want? Well, it's called The Twisted Spur by E.M. Haggerty. Right, Haggerty. There he is. Haggerty. Spur Twisted Knee. Okay, let's see. You have that URL. I didn't record the recording, but I gave you the copy of the URL there. This first one, it's a comedy. This goes to the idea of indexing. Now, when you create an index in a database, first of all, anytime you create primary key, you are creating an index. A primary key is an index. Indexes come in two flavors, essentially. You have what they call clustered indexes and non-clustered indexes. So if you look at the syntax of creating an index, that's probably the most important thing. There can only be one clustered index, and that is usually, most of the time, the primary key, but it doesn't have to be. A clustered index means that the database is physically ordered by that index. So in a library, for example, the call number of the book is a clustered index, because with that call number, it takes me to the exact place in the shelves, and everything in the library is ordered by that. So call number XXXXX1 is right next to XXXXX2, or whatever they're in sequence. Okay, so that's a clustered index, and the primary key is by default a clustered index, okay, a unique clustered index. And then the field is required. Anytime I have a unique index on a required field, I have something that could just as easily be the primary key. In fact, it probably is the primary key because, like I said, there can only be one clustered index. And when you say primary key, you are essentially saying create an index that is a clustered index on that primary key field or fields plural, okay? And make that field required. Okay. So I can create an index that is unique without making it required. I can create an index without making it a clustered index. In fact, if I already have a clustered index, it has to be a non-clustered index. Now, an index in a database works just like the indexes in a library. I said we have an index on the title, an index on the author, and an index on the general topic, 1 or 2 words. Okay. These are the ones we need. We don't have an index on the number of pages in the book. Why not? Silly, nobody ever uses that. We only index things we use a lot. So if I create an index, it's going to be expensive. Indexes are expensive. I want to create an index on large tables, on hot fields. Hot fields. Don't create an index on the primary key. You already have one. Creating a second one will just confuse your database. Probably wouldn't even create it, but don't do it. Don't create an index on a field that you have constrained as unique. If you want to put a unique constraint on a field, that is the same thing as creating a unique index. They are one and the same. Okay. So we constrained a field. For example, we constrained a pair, player 1, player 2, as unique. We said we named the constraint and we said unique player 1, player 2. Okay, that would have been exactly the same thing as saying create unique index on those players. Exactly the same thing. It's not saying they're both required. That's another constraint. Let's see, what else? Indexes are expensive. Indexes cost. A way to decide how much your index will cost is to calculate the number of bytes in that field. For example, if you have a varchar 30, just assume it'll be 30 bytes. Take the worst case. If you have an int, assume it's going to be 8 bytes. It will be. Take that and multiply by the number of records in your database or the number that you expect to have in there. And then add about 30% to that. So take that number of bytes. So I have a number of bytes per record of the index field. So I'm indexing a varchar 10, let's say. Okay, it's going to be 10 bytes per index item. Multiply that times the number of records in the database. So if I have 1 million, that's 10 million bytes. Add about 30%. Let it grow some. Then divide that by 4,000 to get the number of disk pages. You use 4,000 as a rule of thumb for a disk page under Windows. Disk pages are 4,096 bytes. Now I know about, or you can get it in terms of megabytes, divided by, let's see, megabytes divided by 1 million, and that would give you the number of megabytes. You're going to find out that for the most part, if I have 1 million records and I build an index, I'll be lucky to get away with less than 100 megabytes cost for that index. There's a way to find out exactly. I'm talking about just estimating it, rule of thumb. Number of records times the size of the thing you're indexing, add 30%, and then divide by whatever it is you want it in. If you want it in disk pages, divide by 4,000. If you want it in megabytes, divide by 1,000,000. Let's see. We want to index fields that are important to us. What kind of a field would be important to us? Foreign key. Foreign keys are probably what I usually will build indexes on. It is a good idea to index foreign keys unless there is something that tells you not to. What would tell me not to? If it's a small table and it has very few distinct values in that table. For example, I would not index the color of a book's cover. Why? Because, I mean, how many different colors do you have? You got red and blue and green. According to that one, he had a problem with his, what they call the cardinality of the index. It doesn't make any sense to index the color of the book's cover. One, it doesn't have anything to do with anything. And number two, you're going to have a whole shelf full of all of them. Shelves, plural. Okay. Anyway, those are ideas of indexing. The other time that I want to do an index is when I am locking, and we're going to talk about record locking here in a minute. When I lock a record, I want an index on it. Otherwise, if I have to update that field and lock a transaction, and we're going to talk about that, I want an index because that makes my locks run a lot better. We're going to talk about that here in a minute. Let's talk about one that is inefficient. Go here, view. Okay, let's talk about the invoice line items table. I wish I could blow that up a little bit bigger. Notice some things about the invoice line items. Trying to select that one and that one. I can't get it to select them both. Okay, notice what I've got there. Invoice ID and invoice sequence number. What do I have there? A two-factor primary key. Therefore, I have an index built on two factors. I do not have an index on the invoice ID, and I do not have an index on invoice sequence number. I have an index on both of them together. That might become an issue. Now let's go look at the data that are in that table. Hit it top 200. Let's look at the invoice ID. Goes what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, look at this. 12, 12, 12, 12. And then my invoice sequence number goes 1, 2, 3, 4, giving me a unique 12, 1, 12, 2, 12, 3, 12, 4. 13, 1, 14, 1, 15, 1, 16, 1, 17, 1, and so on 1, and lots of ones, and lots of ones, and lots of ones. Oh, look at there. I got 78, 1, and 78, 2. And then I think that's all of it. How could I do that better? How could I design that table in a better way, given that I were designing it from scratch? Now, I think that probably the person who designed that table probably knew exactly what he was doing. And he probably designed the table such that he wanted me to be able to sit here and say, what kind of an idiot designed this table? It's an ID10T table. That spells idiot. Well, now I can't just ditch the column. I still need a primary key. And I need to know what invoice it's tied to. What else might I do here instead of having a two-factor primary key? I want one. that two-factor primary key is going to give me trouble sooner or later. What? Well, I've got an index, but the index is on both fields. Do an identity in what field? Okay. Or I would use a sequence, but same thing, an identity sequence, whatever. I would use one of the existing ones. I would use invoice sequence number as the primary key. Starting at 1, 2, 3, 4, 5, 6. Each invoice sequence number is the same. They're going to be the same as the invoice ID right at first. It's going to be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And then I'll get down here and I'll be at 12, 12. And then 12, 13, 12, 14, 12, 15. Now I've gotten out. I don't care whether they're in sequence or not. I can have 12, 11, 12, 22, 12, 157, and I can still tell you all of the records very quickly because the invoice ID is just a foreign key.
That's sort of like the round ID on our rounds table is the primary key, and then when you look at it in conjunction with games, you've got game ID, round ID.
About the same thing, yeah.
Yeah.
Well, round ID is the primary key. In the games table, the two player names could be the primary key. They are unique, therefore they have a non-clustered index on them. They are unique. The two player IDs together are unique. Therefore, they could be. I don't like it. I prefer not to, but they could be. Would I use a two-factor primary key given that I had to have that two-factor index anyway? Maybe. Maybe. But I'm going to be looking down the road and asking, where is this going to give me trouble? Okay. This two-factor primary key starts giving me trouble right very, very quickly. Because if you look at the invoice line items, look at the fields of it, we have an invoice line item amount. Over in the invoices table, we have a field called invoice amount. How do we calculate the invoice amount? It is the sum of the invoice line items. And this poses a problem. I have to make sure that they are always together and always up to date. Okay. I'm getting a little bit ahead. I wanted to talk about one other thing here today. I'm going to come back to that in just a minute. I wanted to talk about the idea of show plan. Okay. Now, I can find out how my system is going to execute a query. And let me go to this other one. Check and make sure I'm recording. I am recording. Okay. Okay, so this is the second one. This is a short lecture. I think it runs about 10 or 15, between 10 and 15 minutes. And I'm going to put this on. Now, I like this one because this guy is pretty clear. Hey, slow, and it's about appropriate for us. He doesn't go into anything really esoteric about showing plans. He's just kind of giving us the basics of it, how it works. And I learned a lot from it. To be honest, I've never used it in SQL Server. So let me bring this up.
Management Studio, never long.
Do I need to dim the lights or? Popcorn.
Stop on this whole idea of reusability and the benefits of using views, functions, stored procedures, triggers, and all the other reasonable.
I'm going to pause the recording.
Is to talk about that.
Okay, resuming recording. Now, I wanted to try this, and I've got one here. Got this guy, so I want to do show plan with him, and I want to go to query, and I want to display estimated execution plan. So I'm going to click. There, okay, I'm getting it. So this is my estimated execution plan, and if I go to the very top, I see that the go up to the very top of the subtree. Well, if I can, I want to get in there. And, okay, I guess I can't point. The third line down, estimated subtree cost is 0.0129 or 0.0125. That's about what? What is that? 1/64th of a second or so. So, let's see, 0.125 would be 1/8 of a second, and 0.0125, 0.015 would be 1/64th. So that's a little bit less than a 64th of a second for that total query to run. It didn't complain about anything. It didn't say it's not missing any indexes. Everything there is indexed. And if you look at the, everything is hitting either a invoice ID or a foreign key. So this one, I believe I created an index on the foreign keys. So I've got an index and an index. Anytime I am doing a join, if I'm doing the joins very often, and you don't always join a foreign key to a primary key, but you almost always join foreign keys and primary keys. Therefore, a foreign key is a very, very good, probably good one for an index. The difference between using an index and, let's see, did I turn my recorder on? Yes. The difference between using an index is the difference between looking for a title in the library where you have the index. Can you imagine looking for a title in the library if you did not have an index? How would you find it? You just start going through it. There's a joke about the dictionary for masochists. You know about the dictionary for masochists? Masochist, person who likes pain. Well, all the words are there. They're just not in any particular order. So if they weren't in alphabetical order, how would you find it? Well, you just have to go start going through it then. How do you look up a word in the dictionary if you don't know how to spell it? Always wondered that. So anyway, the idea, the difference is huge in using an index versus not using an index. Indexes have a cost. Think of the cost of an index. He said, well, I don't know whether we want to do that or not, but think about the cost. Put an index in the library. When I have that index in the library and a new book comes into the library, what has to happen? They don't just run out there and stick that book on the shelf. What do they have to do? They have to update all three of those indexes. And if a book is taken out of circulation, I have to go and mess with that index all the time. So anytime you have an index, it is going to interfere with updating and delete with any kind of updating on that table. It's going to slow it down. I can still run without an index. One of the examples I use is on day 12. It's called Census Day. What happens day 12 of your college career? You're in the class. Day 12 is Census Day. They ask me, have you done something? Okay. that's why I give you that quiz, you know, about what is your name? What is your quest? What is your favorite color? You have to do something that I can see and point to and say, yes, you actually logged in and turned in something, and you get a point for it or something, whatever. But it also lets me say you were in the class. Now on day 12, if you haven't done anything, you haven't shown up, you haven't logged in, you haven't given me anything, I report you as not attending. Well, everybody, if you're here, you're attending. You're dropped from the roster. Otherwise, you are now in the class. If you drop before that 12th day, you were never in the class. Now, you don't have a grade. It's not a W. It's not an F. You didn't, you know, you don't take a W. After that, you take a W and withdrawn. Okay. It doesn't, if you just don't ever show up for class, you are not counted on the roster for the class. So it doesn't count against your drop tally. Of course, you don't have a grade. You wasted your tuition. You don't get your tuition back. But what do they do at that 12th day of class? They build the indexes. So before the 12th day of class, everybody is changing classes, adding classes, dropping classes. At the 12th day, you can't add a class anymore. Why? Because they've built all the indexes. And now it's a big pain in the neck. Right? You'll never be dropped from that class. You are in that class. If you drop the class, your grade will be entered as W, and you will stay in that class, on that class roster. And it counts against you. So indexing. Indexing is always a hot topic. Now, let's test show plan on a correlated subquery. Let me see if I can, let's see, I go to query and I think I uncheck it. Okay, well, let's see if I, okay, here I have a correlated subquery. What is a correlated subquery? Remember those? A correlated subquery, I have the invoices table, and I name the invoices something, and I named it I1. I have another invoices table, and I named it I2 down in the subquery. And down here, I am referencing I1 and I2 together. Okay, so in this particular query, I am saying, what am I asking for here? Show the vendor name, vendor ID, and invoice total for invoice totals greater than or equal to the average invoice total for each vendor. Not for the greater than or equal to the average for the group, but greater than or equal to the average of that vendor. Greater than or equal to meaning if the vendor just has one invoice total, then that will be the one that's greater than or equal to it's equal, so it'll be in there. So I should see at least one invoice for each vendor who has any invoices. It's not going to show any if they don't have it. Notice it is an outer join. Does it have an outer join in there? Oh, well, this the subquery will many times function as an outer join. Okay, so I have the invoices in the outer table. Then the inner table runs where it references the outer table and the I2 from the inner table. Okay, very complicated query. Correlated subqueries are what give students in 1309 the biggest trouble. I find that if I put them on the test, roughly nobody will get them. Roughly nobody. Exactly nobody. Let's see, if I go to this guy and I click my, not actual, I want my estimated. I go to the highest one and I see it's 0.28 seconds, 0.028 seconds, excuse me. Estimated number of rows it's going to return is 110.647. I don't know how you can return point. That's like having 2.4 children. But if you look at it, that's not a particularly long-running query, but then it doesn't have a huge number of rows to run. Clustered index scan, 12%. Sort. Why is it sorting? So it takes a clustered index scan on what? On invoices, I1. So it does this one first, and then it sorts it. It finds it's best to sort it. So look at that. It's using 44% of the time just to sort this guy. Don't know why it has to sort it. Yes, I do, because he's I1 and I'm getting the vendor IDs. So he finds that if I sort them, I'm going to run a lot more quickerly. I didn't say that. Sometimes it's worth it and sometimes it's not. One of the quotes that I use is, Perry Mason wants his secretary to. Perry Mason was a famous lawyer on TV in a show, and he had a secretary. His secretary's name was Penny, and he gave Penny a big stack of something to search for. Telephone numbers, or maybe it was car license plates or something. Anyway, a bunch of them. And Penny said, "You mean I have to search all of that?" And Perry Mason's response was, "No, you don't have to search all of that. Just sort them and look for duplicates." Well, the cost of sorting is much higher than the cost of searching. So if I only have to search it once, I'm doing a whole lot better just to search, just to plow through it, just pay the cost. If I'm going to do it multiple times, which I am in this case, then I'm better off sorting it first, because this guy is going to run. We're going to have a nested loop running here. So what's going to happen first is this clustered index scan, 12%. Then these two are going to happen. So it's going to sort it each time, puts it together in a merge join. I'm not sure what all that. Oh, here's a bunch more stuff down here. I'll let you look through this. Watch that video again. I think that one's worthwhile. I looked at quite a few of them trying to decide which one I was going to use. And I thought that one was the best. I thought it was pretty straightforward. And so if you follow exactly what he did, you can turn this guy on and off. Well, it did sort. It's showing you what it's going to do. This is its plan. You don't tell it, this is how it programmed itself. You tell it what you want. So SQL is truly an artificial intelligence language. You tell it, I want this output. And it programs itself to go find that output for you. Now, how it does it, and by changing things around in it, you can make, if I said AVG, try it doing count the primary keys, take a fairly large table and count the primary keys, and then change another one and say count asterisk. You'll find this count asterisk will run faster than counting the primary keys, even though the output is exactly the same. when you have a sub-select in there and you are testing is something in the sub-select, if the sub-select says distinct on it, that will cause that query to run more slowly. Okay. I'm not going to spend a whole lot more time on show plan, except very quickly here, I'm going to go to this. Show plan is usually the database owner has the show plan permission. So you can set the show plan all on. Most of the time you don't have to do anything. If you don't have it, you have to log in as the SA. If it says show plan permission denied, okay, you might not be the database owner. So if you log in as the system admin and you say grant show plan to the user you want to have that show plan, now that user can turn on show plan. You have to be the SA to grant show plan. The DBO has show plan, but he or she cannot grant it. If you want the DBO to be able to do so, log in as the system admin, grant show plan to your user with grant option. That means now the DBO can grant other people show plan on that one. Okay, set show plan all on. Execute. Now, when I execute under show plan, let's see. Well, we'll do this one. Already done that. Execute. Show plan is on. Now, notice what I got here is a tabular readout. I can get very quickly, look over here, and I can get the total cost. The cost of that query, remember it was 0.013, which we said was close to a 64th of a second. And as I look down, you know, I see the cost of each one, but the total subtree cost, the cost of that query is right there very easily picked out of it. I can take this and drop it into Excel, and I can compare multiple queries. So this will just drop very quickly and easily. I click copy with headers, and I go over to my Excel. I don't have as fast a computer as that guy has. I want one of his computers. Boy, he was just, when he's just blasting through that, I think I'll just kill SSMS, and boom, and it goes away, and boom. You know, might have been maybe. I know. Anyway, I go paste. No, I don't want to go. Paste, just plain paste. Okay, paste, and I get this, and now I can go in and set my width to. Anyway, and I can sum it and do lots of neat stuff with it. But I've got it here. It makes a nice report. The one I'm really interested in, again, is this guy right here. Total subtree cost, and the very top one of that. That's the metric that lets me compare two costs. So if I want to see one of them, I'll do that. And I personally like this one because I just get him as a piece as text instead of generating all those graphics. And then when you get tired of him, set show plan all off. And he goes away. So now I should get my, if I say execute, yes, I got what I want. Okay, let's take a short break. It is 7 o'clock. Take a bathroom break. Like I say, I don't know whether you guys got my message or not. I'm going to have to leave a little bit early tonight because I got, I always say, I got thrown out of my house. Not really, but they are painting inside my house. So this is, pause the recording. Okay, we're going to go on a little bit further. And we talked about this. This database has an issue. Someone set up the invoice total as a currency field. However, the invoice total should always reflect the sum of invoice line items. And this is a problem. We never store a value that can be calculated from existing data because, well, let's turn it off. Notice that this, what am I suggesting? I'm saying select ILS, invoice total, from invoices as I, inner join L dot invoice ID as IL. Notice that in invoice line items is alias there as L. So I'm saying that I'm taking the invoice total, invoices, invoice ID from invoice line items grouped by invoice ID, taking the sum of them. So in other words, I'm calculating the invoice total from invoice line items, where the one that I calculate, S, the sum that I calculate, is not equal to the invoice total in the parent. Okay. Now, do I have any? Well, I just created one over there. So when I run this, execute this, notice that I have on invoice IL, invoice ID, doesn't matter which one I look at, the invoice ID 12 has a calculated sum of $662.01, and the invoice total is $662. We are off by a penny. Anybody knows anything about accountants? If you're off by a penny, nobody's going home until we find out why. It doesn't care. Okay, so the reason we're off by a penny is that what we have in the invoice line item amount, and add all that up, it doesn't add up to the invoice total. They're not equal. What? No, it's a mistake that I put in there. I'm not going to have a rounding issue on currency because currency, remember, is an integer. And in an integer, I might have an overflow issue, but I'll never have a rounding issue. So I'll never be off by, well, I could have if I were doing something like calculating continuously compounding interest or something like that, where you have irrational numbers. But if I'm just adding them up, I'm never going to be off. And something's wrong. I just have bad data in the invoice line items. All right, so what can I do? Well, here's one thing that I can do. First thing I'd do is get rid of that invoice total. I don't want invoice total. I wouldn't have that in there. But let's say for some reason I had to have it in there. This is the trigger. Okay, I'm going to create a trigger that keeps it up to date. Begin. I'm running a trigger, therefore I do not like multiple line inserts. I'm going to make you do it one line at a time. When I was a kid, I had to walk to school 2 miles through the snow. By golly, we're going to make everybody else walk to school, you know. I'm not going to let you do that multiple line insert into invoices, values, comma, 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 and insert a bunch of them. So basically, I'm going to take the count, and if the count is greater than 0, I'm going to throw an error. We just don't, I'm just not going to let you do that. Do them one at a time. Then I declare my variables. So what's there? We got invoice ID, invoice sequence, account number, amount, and invoice, what is that? INV, description, yeah. And then I select all of these things. I don't know why I didn't make them, spell them out, but I didn't. Select all these things from inserted. In other words, I go out there and I get take all the data from inserted, put them into variables, and here's where I say, oh, I wish I had Oracle here, you know, and I get to gripe about SQL Server. And if I had Oracle, I can just declare one variable and set it easily, but I don't have Oracle. So instead of griping about it, it's a lot better just to go ahead and do it. So I go through it. Now, here's where we start. Here's what I'm talking about now. Begin transaction. When I say begin transaction, everything in that transaction must happen or none of it may happen. Everything has to happen. None of it happens. The point about a transaction. Now, it makes me name the transaction. Seems like I remember older versions. Let me just say begin transaction and commit transaction. I have to have a begin transaction, and this version of it made me give it a name. So I named it T. Now, I'm going to start a try block. I want to catch any errors. Begin a try. Select invoice total from invoices. All right. With UDP lock, and if you look up Google UDP lock, you can see what it is. Basically, that's one of the less restrictive locks. It allows other users to read those data, but people cannot change it. So I'm saying go out to invoices, lock up the invoice total, invoices, where the invoice ID is equal to the one that's coming in to the invoice line items. So I'm inserting into line items, go lock that invoice total. Now, I'm going to let other people read that. I don't have a problem if you read it. If you're okay with taking data that somebody might change, maybe you don't care. If you don't care, I don't care. Right? It's no skin off my nose if you read it. Okay, so a UPD lock is one of the lower level locks. It's fast and it's non-intrusive. So you're allowed to read it, but you can't take a lock on it that says, I mean, I'm going to write it, but if you don't care, I don't. So you have a way of saying that you need to write that variable. It won't let you take a UPD lock because I've already got it locked, and nobody can change it while I'm writing it till I finish. It's read commit, yeah. Mm-hmm. Right. Well, it is. It's not similar. It's a read commit. Right. Yeah, it's an update. I'm going to update it. So a read commit is actually what you're willing to accept. If I say, I'm going to update this, and you read it, that's your problem. Right? If you say you're going to read commit, you could get a dirty read. So it's up to you. It's whatever you're willing to do. Read commit goes to what you're willing to read. I'm going what I'm going to let you read. I'll let you read it. That's fine. But I might change it. Remember when I made you name your constraints, name your indexes? What is that? That's the name of the primary key. The name of the primary key is also the name of the index. An index makes your locks go much, much, much faster. Locking without an index is bad. Now we're going to talk about that. So it's a primary key. Invoice, I'm locking the invoices table, locking a value in invoices. I'm using the primary key to lock it. And this is the where, the thing that's coming in. So I'm going to go up there and lock that row. I'm about to change it. Okay. Now, that has to happen. Now, there is a way I can set a timeout on it and say, no, wait. In other words, if you can't get that lock, just abort right now. Or I can say, because he's going to wait, if somebody else has it locked up, my process is going to block. I'll talk more about that maybe another day. I don't know. Okay, here, this one, I'm going to take a higher level lock on this one, right? I'm going to say select invoice line item amount from invoice line items with, this is the highest level of a lock, serializable. This says that nobody, not only can you not change invoice line items, but you can't read them. You can't go in there and insert something that is going to change that set. So it's a very strong lock, a serializable lock. So here, I think there's 3 levels of locking. I have the lowest level. Serializable is the highest level. I think repeatable read. That's repeatable read. Then there's another one. Well, this is serializable is repeatable read, and there was another one called snapshot that has been declined. Okay, serializable. The index is a primary key, so I'm in good shape there. I'm going to lock up a whole bunch of rows, maybe. Okay, so every place with that invoice ID, remember invoice ID 12 has a bunch of rows, right? So I'm going to lock up 3 or 4 or 5 or 500 rows, right? Because I can't let you insert something that will change that sum. So you can't insert something, you can't delete something. I'm not going to let you read it. I just don't want your grubby little fingers in there at all. Right? Now, let's talk about one other thing. What about this primary key in the invoice line items table? Remember that? We talked about it just a minute ago. What's the primary key of invoice line items? 2 of them. Invoice ID and sequence ID. Oh, this is a 2-factor primary key. I do not have an index on invoice ID. If I ran show plan on that code, I don't know whether I can run show plan on a trigger or not. Probably not. But if I ran show plan, it would be screaming. If I put that in a piece of T-SQL and tried to run it, it would be screaming that you don't have an index. You got a 2-factor index. You can't use half of an index. It's like trying to buy half of a hamster. You can't have half of a cat. Okay, so I want to get rid of that. If I have to have that 2-factor index, I'm going to create an index then just on invoice ID alone in the invoice line items table. Because if I don't have it, what I have to do then is I have to start at the beginning of the table and go through and lock everything until I find the one I'm trying to lock. That means I have to start at the beginning and lock until I run out of invoice ID 12. So I'm going to lock most of that table. Very bad to do. I only need to lock 3 or 4 rows. Okay. So fix that index. But this is the, okay, this is the lower level lock. This one is not as expensive. This is the high level lock that is more intrusive. it's not as nice to the database. I give you a, there's a URL in there to read about locks. But basically these two things, both of these, I'm taking a lock. I'm taking a lock on the table, on the invoice line items, and on invoices. So I'm locking up everything that I'm going to change or might change. Insert into invoice line items. Well, do the insert. And it'll insert. Now, update, declare as money. Select S as sum, invoice line items amount. I can't update it. I can't update invoices. Set invoice total gets sum, invoice line items amount, because they're coming from two different tables, and updating a table join gets tricky. I would prefer, it can be done, but I would prefer to go ahead and get me a variable and go and grab the sum out of invoice line items. Oops, something's wrong here. I need to make a change here. Where? WHE, where are my glasses? Where need to have that. So sum, invoice line item amount, where the invoice ID is equal to the invoice ID. So I grab that value now. I've already inserted it. Update invoices, set invoice total gets S, where that one is. And now, try. Anything goes wrong in there. If anything goes wrong in there, roll back. None of it happens. Undo. This is my undo ability in a database. Make it not happen. I throw an error, usually. And if I get past this, if I throw the error, everything aborts. If I get past that, commit the transaction. Either all happens or it doesn't. Sometimes it will not let you commit in a trigger. Oracle, for example, will not allow you to commit in a trigger. Therefore, remember what we had to do for the writing the errata table, when we were going to write a table, write a log table, and then throw an error. Well, Oracle will not allow you to commit in a transaction. So you have what they call, you do essentially the same thing. You put it over on another server and commit it. And in Oracle, it's called an autonomous transaction. I think SQL Server will let you commit in a trigger. I'll have to run that and see. Okay. Now this is one. Now, one thing we could do with this, I need to run it and make sure it works. I haven't tested it fully. Before I make an assignment and say, we're going to do this, we could do that with a table where we were keeping the winners of the winners up to date, or we could keep statistics up to date. When would I use this? When I need to have that value available to me in the table. Maybe I'm using it all of the time. Maybe I'm using it hundreds of times a minute, and it doesn't change very often. In that case, it would be a big win for me to go ahead and keep it as a value. I don't like keeping things as values that I can calculate. But sometimes you just have to do it. This is how you do it. One time I was working on a database in a bank, and each branch had a transaction log. Everything that happened in that branch of the bank had to write to this log, and they had to keep up to date this certain counts that had to be accurate. And boy, that was a pain in the neck to do. And we didn't have the choice, even though I could have reconstructed them from the existing database. They say, no, these have to be up to date because everything that happens has to read these. So the transaction. Begin transaction. Do not have to have a begin try. I can use if logic. But if something fails inside of this try block, anything fails inside of the try block, we come down here to the catch and we roll back. Okay. If we get past that, we commit. Now, if I were designing my invoices table, I would create a view, invoices, and I would use an inner join and a sum in there. So I would name it alt invoices, or I might rename the table and then rename my view invoices. So I would prefer for invoices to be a view that took that directly from the invoice line items table, then updating it. That would be a lot easier. Okay. And let the create the view. When I create the view, that's going to take care of all the locking for me. When that query runs, it'll do that automatically. You can't update invoice total. You can insert a row, but you can't update invoice total. You can't go in and say set invoice total to something different. You can't add a penny to the invoice total. It won't work. If I add a penny to one of the invoice line items, it is automatically reflected in the invoice total of the view. Any questions on that? That's the simple way to handle it. Oh, I'm not going to go through this code. Hey, run. Let's run show plan. Let's see if you can understand this code. Run show plan on it and see what it does. By the way, remember when I told you to name your primary keys? No, don't just say, field name foo is a char 10 space primary key. Why? Because that just gets the system just names it. And that gives it a very cryptic name. Well, what happens if you don't know what it is? This is how you find them. So if you don't know, if you don't name your primary key constraints, whatever you name that constraint is also the name of the index. That is why your primary key constraints have to be named uniquely in the database, because it's an index. So do your unique constraints. Name them. If you don't name them, then you get to run this code to try to figure it out. And okay, I've talked about locking, and I think I'm going to wrap up there. So next thing I would talk about would be isolation levels. Locking says, I'm not going to let you come in and mess up my stuff. Isolation levels says, I'm not going to read something of yours that's going to hurt me, right? So if I have to have good data from you, I set my isolation level in such a way that I'm not going to take anything from you that might change. You know, if you've locked it and said you might change this, I'm not going to touch it. I'm just going to wait until you're done. So when I set an isolation level and I'm reading your data, I take a lock on your data that protects me from you changing your data. When you do a lock on your data, that prevents me from coming in and changing it. Right? So they both apply to your data, but one of them says when I do isolation level, that says what I'm willing to read. So here I might be willing to read something that you're changing. In that case, I allow read uncommitted or the dirty read. Okay, we're going to talk about that next time. I'm going to wrap up there. What I'm thinking about doing, and you can be thinking about this, is adding a statistics page to the forms. It would be another form, so we don't have to put it in with the others. This could be another form that you start, and it could show you statistics on your game. So if I put in 2 players, player Bob and player Joe, how many did player Bob win? How many did player Joe win? How many ties were there? You could do some percents, some whatever you want to do there. And another one might be, if I just say player Donna, how many games total is she in? How many wins? How many losses? Okay. It would be fairly easy to do using the games table and the rounds table. But what I would like to do would be to implement locking as we did it. Be mostly a back-end thing. Front end would be pretty easy because you don't lock. You lock the back end takes care of the locking. Basically, the form would be pretty easy. The form would just be text windows, text boxes. Run your query and get it back and display it. Okay. I'm going to wrap up there. I'm going to end the recording and the meeting so that I can get this posted. So I am